In this video, we are going to look at naming type 2 compounds. So we're looking at, if I look at the periodic table, something like that, here's my staircase. Type 3 compounds are two elements bonded together covalently that live in the nonmetals. So they're both nonmetals. So there'd be no metals in these type 3 compounds. Okay. So a type 3 compound, like I said, consists of two nonmetals. And to name them, you use prefixes to identify how many of each atom is present. Typically, we include hydrogen as a nonmetal, although hydrogen sort of has its own little system of rules too, but typically we throw it over there with the nonmetals. Also, one major thing to worry about in naming type 3 compounds or writing formulas for them is that there's no charges. They're bonded covalently, they share electrons, there's no transfer of electrons. Therefore, you do not use charges like we had to use with type 1 and type 2. So don't even think plus or minus when you're naming type 3 compounds. Now, there's a bunch of type 3 compounds that don't really follow a normal way of naming things. I guess some of them do, but they're ones that you probably need to memorize. And so here's some type 3 compounds, like H2O. We could call that dihydrogen oxide, but typically we call it water. Or carbon dioxide, CH4 is methane, ethane, NH3 is ammonia, C6H12O6 glucose, C12H22O11 is sucrose. These are just a few, but there are some covalently compounded or type 3 compounds where you just need to memorize the name and memorize the formula. Some of these organic ones, you'll learn the system for naming them in a later chemistry class. Okay, so let's look at the rules. So the rules are basically similar to type 1, type 2, in that you keep the first name the same, and the second one you throw an "ide" on it, okay? But you don't have to worry about charges, but you do have to worry about how many things there are. So you name the first nonmetal, like it might be carbon. So you just say carbon. Like we'll do that one, CO2. So you just would name it carbon. And then the second one, you'd throw an "ide" at the end, so you call it oxide. But then you have to worry about how many of each of those things are. So you use a prefix in front of each of those names, depending on how many atoms there are. And here's the prefixes that we'll use with our system of naming. So if there's one, you can say mono. Often they leave that out. But like if I have CO, usually we call that carbon monoxide or monooxide. And so in that case, we have the mono in there, but we don't have the mono on the first one. I guess we could call it monocarbon monooxide, and I'd probably give you that right on a test, but typically the normal name is carbon monoxide for that. 2 di, 3 tri, 4 tetra, etc. This would be a good chart to memorize, at least up to 6. Knowing those first 6 is good. Maybe octa and deca, those are other ones that you can memorize, but it's good to know all of those. So let's try some examples. Oh, another thing here just in the naming convention. Don't put space between the prefix and the name, and don't use capitals. So for this one, Pi3, I would name the first one, so phosphorus. And then the next one, I'd put it's iodine, so I'd have to call it iodide, not iodine, but iodide. You change that last bit. And then since there's 3 of them, I put a tri there. So triiodide. Notice no space there, also no capitals. There is a space here between each of the nonmetal names. Okay, here's another one. S2O5, so it'd be disulfur. Notice the first one you just leave with the name, you don't put an "ide" on it. And then the second one, there's 5. 5 is penta. So disulfur penta oxide. Notice the "ide" at the end. Got it? Not too hard. Try a couple. I'll just give you a second. Try those 4, pause, and then I'll show you the answers. Okay, hopefully you've done those. Here are the answers. Sulfur hexafluoride, nitrogen dioxide. You could call it mono nitrogen too if you want. Typically, if there's a mono, we just leave it out. So nitrogen dioxide, carbon dioxide, sulfur 4 is tetra oxide. Okay, hopefully that's helping. Now let's go the other way. Going the other way for type 3 compounds is really easy. You don't have to worry about any charges. You just look at the name and it tells you how many of each there are. So you write the symbol for each nonmetal, like nitrogen dioxide. I'd write an N and an O, and then include the subscripts to indicate how many there are. Nitrogen, it doesn't have a mono or anything in front, so I assume it's a 1. I guess I could put a 1 there, but typically we don't put 1s in our formulas. I'll leave it out. And dioxide means I have to have 2 of those. So the formula for that would be NO2. Formula for phosphorus, there's just 1 of them. Penta's 5, so it'd be PCl5. Tetraphosphorus, okay, phosphorus is P. Tetra means there's 4 of them. Hexaoxide, oxide is O, and hexa is 6, so P4O6. That'd be the formula for that. Here's some for you to try. Mark it, set, go. Okay, hopefully you paused and are back. Silicon dioxide would be SiO2. Dinitrogen tetraoxide, silicon tetrafluoride, carbon tetrachloride. Those would be the 4 formulas for those. Okay, might want to practice those. Look online, see if there's some practice for you to look at. Just as sort of as a synopsis for all of the naming that we've done so far, we've done type 1, type 2, and type 3 names. We've seen that type 1 are a metal and a nonmetal. Type 2 are the same, a metal and a nonmetal, but the metal has multiple charges that we have to worry about. And then type 3 are 2 nonmetals. And then you may want to put a chart like this together so that when you're having to name something or write the formula for it, that you can look to see what the rules are, because there's different rules for each one of those types. And you've got to make sure you follow the right rules. Okay, hopefully that helps you out with naming type 3 compounds.